In this video, we're going to be talking about solubility rules. And what solubility rules do is they allow you to predict when a solution will form a precipitate that is now a solid that will be suspended within the solution that you could then actually retrieve and collect. And that's really when you have an actual reaction in a solution, is when a solid forms, or sometimes you can form a pure liquid or a gas. But anything that's out of phase, that will drive a reaction to go forward. So when you're predicting whether or not a compound will be soluble or not, we got to use this list of rules. Really, these are mostly based off of Coulombs Law, which states that the force of attraction is going to be proportional to the positive charge times the negative charge over the distance between them squared. For the most part, we can ignore the distance part and just look at the charges of the ions. And we can use that to predict whether or not something will be aqueous or dissolve, or if it's going to precipitate and form a solid. So if the numerator in this equation gives you a value greater than or equal to 4, that means it's likely to form a precipitate and be a solid. If the numerator gives you a value of less than 4, that predicts that it's usually going to be aqueous. Now there's a couple ions that are common exceptions to that. Silver, while it's +1, that being multiplied by anything -3 or smaller for a charge on the anion, should predict that it would dissolve. However, it usually results in the formation of a solid. Same deal with hydroxide. Even though it's -1, which usually would lead to this resulting in a value less than 4, it also forms a precipitate most of the time. And sulfate goes the other way. Sulfate's -2, so paired up with any metal that's +2 charge or greater, you would usually predict that based off of this, that it would form a solid. However, it typically will result in the formation of something that's soluble. So this can be used for the vast majority of compounds, and on this list you don't have every single metal ion you could possibly encounter. If it's something that's not on this list, then just use this law to predict whether or not it's going to dissolve. Again, a product of the charges greater than or equal to 4 is going to result in the formation of a solid. Less than 4, aqueous, with those exceptions. So most things that are usually are pretty much always soluble without exception. Salts of alkali metals, so sodium, potassium, lithium, those are usually going to form soluble compounds, or AQ in solution. I mean, you'd predict that from Coulombs Law, because if it only has a +1 charge like those, it should not result in something greater than or equal to 4. Also, ammonium would be included in that category as well. For anions, nitrates are always soluble. They'll dissolve with pretty much anything. Chlorates, same deal. Perchlorate, same deal. Acetate, same deal. Some exceptions there, actually, even though it's not noted up here. Silver will actually form a precipitate with the acetate ion. Pretty much all salts of halogen. So if you have anything combined with chloride, bromide, iodide, those are usually going to be aqueous in solution or dissolved. Couple exceptions to that would be some heavy metals. Silver, mercury, and lead. Those typically will form precipitates with these, but not much else will. Compounds containing fluoride. So fluoride's a halogen, just like these compounds, these ions. However, there are more things that will precipitate with it. You can see that it will form precipitate with magnesium, calcium, strontium, barium, and lead. And the reason for that is that fluoride is so small as an ion that it actually gets really close to the other ion, and it requires a lot of energy to overcome that attraction and pull the ions apart in solution. And you can actually predict that based off Coulombs Law. Because it's such a small ion, it's going to have a greater force of attraction holding it together as this value gets smaller, as it's going to have a low distance between the ions. Sulfates, again, are usually going to be soluble with those exceptions. So you have the alkaline earth metals and lead in there. Things that usually will form precipitates. And you kind of would predict that based on their charges. So carbonates will usually form precipitates. Phosphates, oxalates, chromates, they'll all form precipitates, with the exception of salts of the ammonium and alkali metal ions. Again, these are soluble without exception, so even if they're paired up with something that's really insoluble, most of the time, it's still going to dissolve. Sulfides, oxides, and hydroxides, those are all also going to be insoluble most of the time, with the exception of the alkali metals and ammonium. Now, real quickly, I just want to go over what happens when you mix a couple compounds that are dissolved in solution. So first, I'm going to go over a reaction where it's not really a reaction. If we mix a solution of sodium carbonate and potassium nitrate, those are both aqueous because they both contain, an alkali metal. Now, the products that you would get if you predicted the products for a double replacement reaction would be potassium carbonate which, since it contains potassium, would be soluble, and sodium nitrate, which would definitely be soluble based on our rules. So if that happens, what's really occurring is you just have all these ions floating around in solution. None of them pair up and form new partnerships or really form a precipitate. You really just have a solution that contains all of that stuff dissolved. So we would say that that's no reaction. However, if you mix two aqueous solutions that result in the formation of something that would be insoluble, that's a real reaction. And that would be something with a driving force that would be a double displacement reaction. So in this example, we have sodium carbonate, which breaks apart into sodium and carbonate ions in solution, and silver nitrate, which is aqueous, which breaks apart into silver and nitrate ions in solution. However, when you swap the partners and you predict the products, you see that silver carbonate, carbonate's usually insoluble, and silver is definitely not an exception to that. So that's a solid compound that forms when you mix them. So what you would observe is a white cloudy mixture that eventually settles out over time as the solid collects on the bottom of the container. That was a reaction. This is now removed from the solution, and what you would be left with is these spectator ions of sodium and nitrate that are just still be floating around and haven't really done anything. So these are the solubility rules and where they come from, and this is how we would apply them.